Welcome back to Element 14 Presents. I'm Clem and you are a predator and I can prove it. Your eyes are at the front of your head. That's the proof, because if they were on the side, you would be a prey animal, like a rabbit or a deer. But how do they look? Like, what's the view from the point of view of an animal that has the eyes at the side of their head? Well, there's only one way to find out. Okay, there's actually two ways. Let's do the non-so-gory, less bloody one with cameras and computers involved, shall we? At least as far as I remember from school 20 years ago, prey animals have the eyes on the side of their head and they can view their surroundings more. And that also means that they don't see very much what is directly in front of them, and it doesn't matter to them. It's more important that wherever predator lurks at them, they can spot easily and then run away. For predators like us, it is important that we have depth perception, so we can actually target our prey and go directly to it and always keep it in focus. But what if me, guy with the eyes on the front of the head, would suddenly have the eyes on the side of the head? I want to emulate that, of course, with technology. So I'm using cameras, computers, and some Python. So of course my first task is to gather the materials. I'm using a Raspberry Pi 5. I'm using two wide-angle cameras. And this is of no surprise because we have two eyes, of course. Wide angle because the eyes of prey animals usually have a much more wider field of view than we currently have. And because the Raspberry Pi 5 has two camera connectors. So I can use two cameras at once with it. And also it has the processing capabilities to stitch the video in real time and then give that to a screen. So let's see if we can actually emulate that view at all. The Python script that runs the whole thing is actually quite simple. It still needs a lot of processing, but technically it's not that impressive. What we need is to capture both images at once. Then we have to interpolate between them, because interpolation, that's how your brain makes sense of two images that it gets from both of your eyes. And that's the reason why you can't see your own nose, even though it is within the field of view. And you can try that out by moving it to side, and suddenly you will see a bit of nose and a bit of finger, and it looks transparent. That's because your brain is interpolating these two images. We do the same in code. Depth perception is only important if both of eyes, or it only works if both your eyes look at the front. So if we want to emulate something that looks to the side, prey animals don't really have any depth perception, to my knowledge, and so it's not important to them at all. And that also means that we can get by with very simple image stitching to emulate whatever a prey animal would look. So we can put this onto a regular flat screen and it would still be like a convincing simulation. Watching it on a flat screen, of course, is cool and all, and you can already see that the view will be very weird, but full weirdness only happens if I put this on some goggles. I'm using some cheap FPV goggles to get a screen directly up to my face. And I have to feed the signal in there somehow. They take in composite video. My screen takes in HDMI. To capture whatever I see for you, I would like to output it on both. And this is where the first trouble starts, because you can't actually do that. On the Raspberry Pi 5, you have to solder the composite video header yourself. There's no dedicated port for it anymore, but there are two pins, signal and ground, for your composite video. So you solder to that and put it into the goggles. But you also have to, of course, activate composite video in software in Raspberry config. That also makes sure that HDMI will be disabled. Sadly, it can't output both at once. So we have to find a different way of capturing the view from inside for you. The Raspberry Pi has an awesome feature. It has enough processing power to enable network streaming. So I can stream the image over a little web server within my Python script to any computer in the network. So I just access the Raspberry Pi's video feed with a different computer over a browser and do a screen capture with that computer. And this is how you can see what is actually going on inside the goggles. Neat and properly formatted code is not my strength. That's why I let an LLM do that work. But you can download all that neatly formatted code now for free on the Element 14 community, and of course also the 3D files that I use to mount the Raspberry Pi on top of my goggles. Just a few files, they are mostly there to hold the cameras and the Raspberry Pi in place and let me keep the cables somehow out of the view. Fun fact, because my eyes are now to the side, it doesn't really matter that there are a lot of cables hanging in front of me. I can see them anyway, so they don't hurt my experience at all. These might be the weirdest FPV goggles ever. It's my own first-person view, just as if my eyes were mounted on the side of my head. And these are IR cameras, which means I also could see better in low light situations or where only infrared light is present, which also is more like a prey animal. So it's kind of 2-for-1 deal. I'm not looking forward to the experience because the image on the screen already freaked me out a bit. Let's see if I can actually perform a simple task with these goggles on and still adapt to it somehow, or if this will just induce vomiting right away. Okay, we're trying this out for the first time. My first test of having eyes on the side of my head. I'll put this on. Okay, this is very uncomfortable. Okay. Okay, I tried to... Oh god, this is so weird. Okay, I have to measure the battery, which I can't see. I found the multimeter, and here are the leads. Okay, if I hold things in front of me, I can't, and I interfere with cables, so... No. Oh, I have to move my head to the side to be able to find the ends of the leads. Hello, there's the camera. Okay, so... Colors are a bit of a problem. Okay, the multimeter is turned on. So how do I place this now? Okay, somewhere is a battery. Oh, what? Wait. If we go like this, there's a battery. Okay, to line myself up very weirdly. Contact the battery. Now I'm moving my head in the totally opposite direction. I can't read it. 1.3887. Okay, so next task, write that down. Oh, my wrong hand. Okay, I got the paper. Okay, 1.888. No. Okay, why is it hard to write? 1.8, no, it was 1.3887. Why is it so hard to write now? Okay, write it on the back again. 1.3887. Yeah. Can't see anything that's directly in front of me. I have to do everything to the side and switch sides. Okay, and now I'll turn that off. Put it into this thing, fold that up, and the battery. Where's the battery? There's the battery. And that's time. God, that is weird. Okay. I'll do it again, and now I move the eyes even further apart. So these are like exactly at 90 degrees now. This is more than any animal in real life actually has. Don't need that again. Battery, open that up again. Just reset the whole scenario. This is where the battery goes. This is okay. Let's do this a second time. Let this record. Oh God. It only gets worse. Okay, I can't see a thing. Okay, this is now completely... Oh. Don't move too fast. Okay, there's the multimeter. There it is. Okay. Get the leads. I'm mostly doing this by touch, not by seeing. Okay, oh, turn it on. So we're gonna have to put this completely to the side of my head. Okay. Set it up somewhere. Okay. Find the end of the wires. Yep, these are here. Okay, I have one here, I have one here. There's the battery. There's the battery. Okay, I have the battery in front of me, and at the moment I'm just doing it by touch because I don't think I can really figure out where the... Okay, I think I've touched them. I have no chance of seeing the... There it is. Not touching correctly. 1.3886. Okay. It's making me quite sick. Okay, there's the paper. 1.3886. Can I read this? Okay, I count that as something I wrote down. Okay, fold it up. And now into the box it goes. Where's the box? There's the box. The hand-eye coordination is not that bad once you have a frame of reference. You treat it as your normal view. Okay, where's the battery again? Hello? Battery's gone. Okay, I'm only searching it by touch because I have no chance of seeing it. It might have fallen down, so can't find it. I'm finishing up the box. I call that as I'm almost puking. There's the battery. Ah, this is not eye strain. This is headache and weirdness inducing by far. Oh, wow. This is not pleasant. But it's like the one with where it just moved the eyes out of, like the realistic one. That was manageable. Like I see how animals with the eyes on the side of their head could actually manage to go about their lives. It's totally believable. I couldn't do it. Wow. My brain is a bit, like, I'm not feeling well at the moment. So I managed to do the tasks in the more animal-like configuration. It was hard, but I actually managed to do it. In the full-on 90-degree mode, it was almost impossible. And with that, the weirdness gets so strong that I had to throw up a little bit. And in my mouth, and it wasn't pleasant. I had to like sit down for a while and relax. I just finished filming the demo of my weird eye goggles, and I'm still having a headache. I'm walking outside just to clear my head and get fresh air. I still have a headache. This is so straining mentally, and it's very weird. Don't do that. So this experience is not pleasant. It's weird, but it's actually kind of doable. So could your brain adapt to moving your eyes to the side of the head? Yes, you could do it. Is it pleasant? Nope, not at all. Might it be useful? I doubt it. But anyway, if you want to throw up yourself into the goggles or mess up your brain, be my guest, download all the files for free on the Element 14 community and share your weird project ideas there. Maybe we can build some of these. I gotta go. There's another project waiting for me.